This is the welder we usually have set up for aluminum. Right here you can see it's set to AC. The high frequency is on continuous. That's what you want for aluminum. This is the same as the other machine where it doesn't quite tell you exactly the weld current, but if you load the machine up you'll see your volts and amps there. But usually we don't mess with this because it's got a foot pedal. That's your power on button and it's set to remote. Your intensity for high frequencies right there, I wouldn't really mess with that. Sometimes if you're getting intermittent like high frequency starting, you have to adjust the points in these machines, but that's a video for another time. This is your water cooler, so make sure there's water topped up in there because welding aluminum causes a lot of heat to build up in your gun, and the argon's turned on, so we should be good to go there. For the tip setup, what I like to do is you can either have a sharpened tip. Sometimes it'll get a little ball on the end of it, like it's gotten right there. That's fine. Generally with aluminum you don't need to sharpen your tip. If you're welding finer things, it's not a bad thing to get, but you know, you want to make sure you're not sitting there too long and your electrodes not jittering around. Sometimes what you have to do is just sit in that spot, let it heat up, and it'll be a little bit better. Sometimes you got to sit there when you start welding for a few seconds and let the area. You're not going to be able to bump tack. You're going to have to use filler a lot of the times. It can be done, but aluminum can't be TIG welded without filler. It'll crack often. So like I'm going to get set up. I'm going to hold the TIG wand usually like that, and for the filler metal it's going to be very similar to stainless steel welding, where I'm just going to, you know, pause, dab it in there, move, pause, dab it in there. And you just go from there. This is a piece of metal that I pulled out of the scrap, and this is a bit too dirty. Like I'd be careful welding that because you're gonna have a lot of issues. It's gonna look bad. Or you can help it. You try not to have like any contaminants, and that includes like grinding disc debris. Like when you grind aluminum, it's gonna embed the abrasives into the parent material. So you can see I started my arc and it looks a little bit wobbly once it starts zooming in, and that's an example of not letting enough preheat time soak the heat in, and that can cause your tungsten to melt and fall off, also creating some issues, and it can put too much heat in. But when I'm welding, I'm releasing the pedal because the heat is now catching up to the weld bead, and slightly I have to pull back on the foot pedal just to keep the bead the same amount. So you get a feel for it after time, but it's not like you hold the pedal in one position. You're kind of you start it off a little bit more and then you start feeding it off backwards a bit because the plate's heated up. So you can see right here I've started the arc, and it's going to take a few seconds for the material to heat up, and I'm careful to put the aluminum rod in there, just touching the molten puddle, and I pull it away so it doesn't melt. This is different than the lay wire technique. This involves a little bit more coordination, but you can kind of get an idea and see the ripples in the background. Here's another shot of this. So you can see I'm starting, just letting it sit for a second, and I'm dabbing, pulling the filler rod back quickly. This is a good example. This weld has some contaminants coming through. Closer to the end, you'll see the arc get unstable, and it actually almost looks like it pops. And that's just that's either the tip of the electrode touching into the molten metal, and it's going to create some black haze on there. So be careful of that. Make sure things are nice and clean. Even something like abrasives from grinding discs can embed themselves in there. Sometimes it's easier to use like a carbide burr and some WD-40 to keep it from gumming up, and then what you can do is just clean it off there with lacquer thinner. Even too with the welding wires, when you get your welding electrode, you want to make sure it's nice and clean, so I'll wipe it down to make sure there's no dust or contaminants on it. Your weld puddle will start to be, you can see impurities pull up through the material, and you can almost see black little specks in there. So it's just even from the side of this edge, like You want to make sure that edge is nice and clean because it'll pull all the dirt through it. If you get some black, that's either from touching the tip with the electrode while it's molten. It'll shoot some black stuff out at you. What you can do is just make sure it's all cleaned off again before you start. The other thing that can happen is if you don't have the proper gas flow or your tip sticking out too far, it'll look like that, and it's going to give you a lot of issues. These 2% lanthanated 1/8 electrodes are what you want to use, and like I said, you can choose to sharpen them. Just put a dull point on it, or if you're welding thicker stuff, it'll actually create a ball. Just you don't want your ball on the end of the electrode when it forms to get all wiggly and it'll start melting. So that's kind of a sign that sometimes you might need to preheat your aluminum with a torch, or you can just sit with your arc on there for a little bit longer and it'll soak some heat into the product, because aluminum is gonna, like, you're not going to be instantly able to start welding that. It's going to create a bead. Like your tungsten's going to start melting, and you're going to force too much heat into the aluminum and it's going to sink through. So like something like this, like I think I was sitting there for about 10 seconds, and this is 1/8 aluminum. So something thicker, you might have to sit there longer.